My name's TOBYN Hughes. I'm the Managing Director of Transport North East and the Director General of Nexus. We're here this morning in the Metro depot in South Gosforth in Newcastle. And we're here because it's a really important time for the Metro. Today we are marking the fact that the depot is shortly going to be reconstructed as part of our fleet modernisation programme. Normally we would be having an open day for people from the general public and our customers and our staff to come and visit the depot for an important event like this. But because of the coronavirus crisis, everybody has to do things a bit differently. So today we're offering everybody a virtual tour of the depot instead. This is a really important time in Metro's history, and of course, its future too. The Metro train fleet is over 40 years old. And even though it served us and the area really well over those 40 years, we're getting a new fleet of Metro trains. But the reason we're here today, of course, isn't just about the new fleet of Metro trains, but we're also rebuilding the depot in which the trains are housed. The depot we're at has been here since 1925. It was built by the North Eastern Railways, and it was here to serve the first generation of trains that served the area using a third rail electric system. Over the years, not only has this depot housed those trains, but it's also housed steam trains. It's housed diesel trains. And since 1980, the fleet of Metro trains which are now heading towards their retirement. Over the next few years, this depot will be fully rebuilt and turned into a very modern, purpose-built set of facilities for the new fleet of trains to be maintained. This is a fantastic facility that's been looking after Metro trains for 40 years and all sorts of other trains for about 100 years. So please sit back, enjoy the tour and see a bit of history unfolding in front of you.
Morning all, thank you for coming to the depot today. My name is Mark and I'm the Fleet Maintenance Manager. I'll take you around the depot today to have a look at the equipment that we've got in use and the Metro cars in place. Can I make sure you've all got your high-vis, safety glasses and safety boots on and stay within the yellow lines at all times please. So we're now heading into the maintenance shed. Maintenance shed is where we carry out fault finding and rectification of in-service failures, planned component and asset changes, as well as exams. This is the lifting shop. The lifting shop is where we conduct heavy maintenance activities. This includes major component changes, such as bogie frames, transmission assemblies. We also conduct internal overhaul of our assets and components. Within the lifting shop we've got 2 unwired roads with 4 berths able to accommodate Metro cars. Each berth has got a set of jacks which allow us to lift the Metro car in the air and remove components from beneath the Metro car.
I'm KIERON and the reason why the Metro's in the air is for something called a D exam, and the wheel sets need to be taken out of the car, and so in order to do that, that's why it's been raised by the jacks.
This is the wheel press area. In the wheel press area we strip and also build axles. When the axle is bare we then fit mega couplings and gearboxes and fit the tyres to the axle prior to then being assembled as part of the transmission assembly and fitted to the Metro car.
I'm and I'm a mechanical technician for the Metro. This is the wheel press area, and what we do is we build axles for the trains, starting from components to fully built up axles. So the two different types of axles we've got a trailing axle and we've got a motoring axle. The motoring axle is powered by obviously the motors, and the trailing axles are free running axles. The difference between these axles are 2 brake discs on 2 axles, and the other 4 axles have got single brake discs. That's how we can tell the difference. And the gearboxes on them. The gearboxes drive with axles through the flexible coupling disc on them because of the solid axles that we use, so they are a bit of a damper for them.
This is the tyre press area. This is where we strip and assemble wheels.
My name is Paul Brownlee, I'm the heavy production manager. We're here at the tyre press. The tyre press is here so we build the new tyres up from scratch. We get the new tyre in, we have an old outer which we refurbish. We then put the new tyre onto the press. We'll put new shunts in with 3 copper shunts. We then press the inner in. The reason for the copper shunts are for the continuity of the wheel. That's so that you have continuity from your wheel through your axle, so that you have the continuity for your track circuit when on the main line.
We're now heading down 3 Road and into the machine shop. In the machine shop, this is where we conduct any machining of our components. What we also do in the machine shop is we overhaul controllers and camshafts, as well as power heads.
My name's Kurt. I'm one of the day shift electricians. My job at the minute is to actually make spare parts, which is this little beast here. This is one of them. What these are for, this is just part of the speed control for the train. Obviously it's old technology, that's why it's so big and heavy, used in heavy industry, and all it does is we get 1500 volt DC on the overhead line, so you can't switch that straight through to a motor, otherwise it would be. So what we've got is a big resistor bank. All of them come in series first and reduce the power to the motor. This runs up, these switches close, and as they close they shorten out some of the resistors, which means you get less resistance, higher voltage, and that's your power to the motor. Simple as that. So in here we build the main cams up like this, and they provide the power and the braking capability on the trains. So Brian does the power heads, and all they do is drive the cams up and down after the control of the driver from the other units over there.
Coming out of the machine shop, we continue down 3 Road to the pantograph maintenance area.
This is the pantograph, which sits on top of the metro car basically, and it draws the electricity from the overhead line back down through your traction motors, back down through the car, through the traction motors to the track, which actually powers the metro car. After the pantograph has been stripped down, cleaned up, basically you have to build it up stage by stage and set the pressures, set the heights. You start by fitting the force spring. That is called the right hand spring because you actually look to the pantograph from that side. The right hand spring, that sets your housing force, which actually is the force required to raise the pantograph from the base. You set that to 79 to 85 Newton meters using a spring balance, which you attach to the far end of the pantograph. This spring
does two things. Depending on how far you screw it onto the fourth thread, that determines your pan height. And this one determines the force, which is actually on the overhead line.
Now continue down 3 Road to the bottom of the shops and cross over from 3 Road to 4 Road and into the wheel lathe area.
So I'm Dex and I'm the engineering technical manager here at the depot, and this is our wheel lathe. And basically we'll bring a car in, raise it up, and we'll take little bits of millimetres off the wheels to take out any sort of any pitting or any flats to make the wheels perfectly circular so they run nice and smooth for the customer. This is an 18-ton machine, and typically brand new wheels will come in at sort of 740 mil, and we'll take them down to about 660 millimetres.
Now we'll move down 4 Road to the auto coupler bench.
We're here at the auto coupler bench. This is where we overhaul auto couplers. What the couplers consist of is it's a coupler head and a draw gear. They couple the 2 Metro cars together, both electrically and pneumatically. The mouthpiece, coupler mouthpiece connects it pneumatically, and then you've got a coupler block with electrical pins in it, which couples it electrically.
We're coming out of the lifting shop now, back into the maintenance shed. As we cross the centre path, we'll be heading into the running sheds. So this is the running sheds where the cars are stabled when they return from service, and also stabled in this area overnight. As we head outside of the running sheds, we go to 16 Road, which extends through to 20 Road. The fenced area is 17 Road, which is a train stop equipment safety test track. The train stop would put an emergency stop to a Metro car if a signal was passed at danger. So we now come to the end of the limits of the depot, and we now pass over into Nexus Rail headquarters, where we come to the road rail vehicle.
So my name's SHIEL, I'm head of maintenance delivery for Nexus. What we've got here is a Unimog U400, which is a overhead line road rail vehicle. What it constitutes of both road and rail guidance wheels, which means you can drive it on the road and drive it on the infrastructure. It's got on the back of it, it's got a mobile elevated working platform, which in essence is a scissor lift. It's an access platform that allows our staff to maintain the overhead line infrastructure. It also has a pantograph, which allows us to take measurements of the overhead line contact wires, and to assess what the height of the wire is, or what the stagger of the wire is. So what you can see in the cab is it's got various safety features. It has a diagnostic screen that tells you everything about how the machine's performing in both road and rail mode. It also has a reverse camera that you can see behind you, obviously for when we're on tracking machines. It's got a front camera on the pantograph, which actually allows us to capture the overhead line from within the cab to assess any critical defects. Right, so in the event of a disruption, this will be one of our first fleet machines that'll be on site on our infrastructure, specifically if it was an overhead line disruption. this would be on track at one of our level crossings or road rail access points in a possession of the line, and there would be an isolation of the overhead line undertaken prior to putting this machine on, and this machine would be responsible for repairing all the defects associated with any service disruption.
As we come into Nexus Rail HQ, we come into the automatic fare collection workshop.
Hello, I'm Steve Griffin. I'm the technician from the workshop for the FC department, which is the automatic fare collection department, and we look after and maintain all the ticket machines on the Metro system. And what we do here in the workshop is the parts that get defective outside. We have 12 lads who are out in the field, they go out in the vans, and they're the ones who bring defective parts into the workshop, and we repair them here, and then they get reconditioned and go back out into the field. And out in the field, these machines get a lot of use, a lot of punishment. The sort of things that we get happening is if bent coins, damaged coins, dirty coins and everything. You know, money is very dirty, and it tends to, through a period of time, if we allow that to build up, it'll sort of stop the machine from working, you know. And so every so often, every 6 months, every machine on the system has to be cleaned, maintained. We have a swap out system where certain parts are taken out, brought back here, and reconditioned parts are put in.
Hello there, my name is Paul Patrick. I'm currently the Head of Fleet Engineering here at Metro. I'd like to take this opportunity to thank you for your visit today. I hope it's proved valuable for you to see what goes on day to day behind the scenes here at Metro. I hope you've had a good time with my staff, seen the depot facilities and the trains. However, as you're aware, the trains are very old and so is the depot, but the future's bright. We're currently going into a new phase where we're going to provide new trains and new depot for the North East, so watch this space.
The future of Metro is looking really bright. The contract that we've awarded to Stadler means that we'll be getting new trains starting to arrive in the next couple of years, and they will transform the experience that passengers have on the Tyne and Wear Metro. The new trains firstly will be able to carry more people at busy times, and they'll be hugely more reliable than the fleet of trains that they replace. They'll also have lots of modern features inside. They'll have Wi-Fi for passengers to use, they'll have charging points for their devices, they'll be much more comfortable, light and airy and secure feeling, and all round they are going to really change the way that people travel in this area. With brand new trains and a brand new depot, the future of the Metro is really exciting. Metro has served this area fantastically well for 4 decades, carrying over 36 million passenger journeys each year. It takes people to work, it takes people to school, it takes people to all the big and small things that make up their daily lives. Metro has been part of everyday life for 40 years. As we look to the future, we are proud to continue that connection with the people of the North East.